Welcome back, guys. It's Israel. If you guys are developing modern applications, I'm sure you guys have heard the term microservices. But what is this architecture that seems to be used everywhere nowadays? Why would you even want to use it? Well, that's what we're going to dive into today. What is the microservices architecture? Let's go. But first, just want to give a quick shout out to my channel members. If you guys want to support the channel as well as show up here and get access to any code from any video on my channel, click the link in the description or the join button on my channel page. But now, onto the video. So like I said, we're going to be talking about the microservices architecture. What is it? How do you choose what should be its own service, as well as what technologies do you need to make the microservices architecture even happen? And really the main comparison here is taking and looking at the monolithic versus the microservices. Monolithic is going to refer to basically your whole application being in the one VM, server, wherever you have it, computer, wherever you store your application, the whole thing is in one big box. So you don't have individual pieces that you can a little bit more bite-sized to handle if you need to make smaller changes. Everything is in one big box, one big environment. Versus you have microservices, which each little piece of the application or API or whatever you want to call it is its own little bubble. They're more detached and they all communicate with each other to build and make up your application. So I'm sure just with seeing this image, a lot of you guys are already thinking of different ways of why the microservices architecture is really good to use just by looking at this image. So what are microservices? It's an approach to building a server application using a set of small services. These services then communicate with each other using HTTP or a few other channels of communication. Okay guys, let's think back to slide 1 where we had the big gray box, the monolith app. So in there we have the UI, API 1, 2, 3. Let's say that in API 2, we need to update one package. Well, we make that change, but we can't just deploy API 2 by itself, run only API 2's tests, and whatever else it needs to be deployed to production. No, we have to run it for our whole application. And let's say API 2 has some type of error that bubbles up to other places. Well, that means that maybe our whole application goes down and we have to redeploy everything. So that is one possible issue with this approach. But now let's look at the microservices architecture. Same scenario. We have API 1, 2, 3. We have a gateway, which would just be the thing that kind of communicates and sends the requests off to your APIs. You don't need to have one, but you can, as well as you have your UI. So same scenario. API 2 needs an update of some sort. Well, in this case, this is deployed, this is deployed, this is deployed, and this is deployed, all in its own microservice. API 2 is deployed by itself, maybe with a database or whatever else it needs. So with that being said, the only thing we have to do is just make sure API 2 works and run its test and deploy it by itself because it's its own little bubble. So that avoids us even having to touch these. As well as, let's say API 2 has some fatal flaw, well, then just this endpoint doesn't work, but everything else continues to work with just some errors, right? So the whole application doesn't go down. So that's just another way that microservices and that type of architecture can really help us make our application work better and smarter and make it easier for us to manage all the individual parts. And with that being said, let's go more into the benefits of this architecture. It splits up the APIs or pieces of the app into smaller services, allows the ability to not stress about updates happening across the board or one piece crashing, like I mentioned in the example before, and then the whole app going down and having to redeploy the whole thing, just the given piece that might be broken. It allows your services to be loosely coupled as well as easily scalable versus the monolithic approach, which you would then need to make multiple copies of the full app on multiple servers or VMs. That was the big gray box and everything inside of it. If I needed more capacity to handle requests, I would need to make a full copy on somewhere else instead just maybe saying, oh, well, this given API is the one that's really being stressed. Let's just bump up its capacity, right? You would have to do it for the whole app, right? Which could be more costly in the long run as well. And it allows for failures to, again, not cripple the application since the failure would be isolated to just the given service that's going down, not the complete app. So how do you decide what should be a service? Well, each service should handle its own piece of the application. So it could be a search engine. It could be the part of the application that handles payments or everything around that, or it could be the thing that handles user profiles or anything to do with the user information. Those are good examples of things that could be services, right? They handle everything within its own self, and it doesn't depend on other things, which is the second point. They should be able to complete their function without high dependency to another service. And if it's decided that a piece of an app should be a microservice, then it should have its own repository, CI/CD pipeline, and environment. Because what you want are loosely coupled services, so you have autonomy when it comes to development, scale, and deployment. Because like I said before, if let's say our search engine is being swamped, then we know that just our search engine is what we really need to scale up so that it can handle all the demand. But maybe, our payment processing is fine or something of that nature, right? So again, allows you to be more flexible versus the monolithic, which we would need to just do full on copies and copies of our app to make sure that we can handle whatever stress is coming in. So the most important aspects of a microservices-based app is that the microservice architecture is more for the backend, right? And microservice enables the creation of complex, large, and scalable systems using many different and independently deployed services to make up your app. So then the other important aspects are that you need to monitor the health of the services and infrastructure. You need to make sure that you have a scalable infrastructure for those services, such as something like the cloud. You need to have security at multiple levels, since a lot of different services will be communicating with each other. And then you need to have DevOps and good CI/CD practices. And if you guys are finding this video insightful, please drop a like and subscribe to the channel so you don't miss out on any of the other content that I have for you guys. So finally, what technologies would you need to use with your .NET APIs if you wanted to do this microservices architecture? Well, you're going to have to embrace containers and Docker. Docker containers are what are used to host your services. Containers are what efficiently run your microservices in their own isolated environments. So that's going to be it for part 1. In part 2, I'm actually going to dive into what are Docker containers, and I'm actually going to show you guys an example of how you set up your .NET API with its container for this microservices architecture. So I'll see you guys in the next video.